This is Algebra 2, Unit 0, Lesson 2. We didn't do Lesson 1 because we ended up realizing that it was way too easy. Let's see, do we have, yeah, this was Lesson 1. It's just coordinate plane. We realized everyone could do that, so we're going to go on to lesson. And I see a question from Chris. Good. All right, so degree of largest term. So I'm just talking about the power here. So if you don't know degree, this word right here for degree, I'm just looking for the power. Some of these are a little bit hidden, and I think this is hopefully review for a lot of us, but maybe not, we'll see. So let's go ahead and turn this guy, this polynomial that I've written up here, into a chart, or table rather. So there's my table, and I'm doing a line right here, a line right here, and I guess, sure, a line right there, even though it's not part of the polynomial. Quiet raise hand. What is the degree of x squared? With a quiet raised hand, is there anyone out there? There's one person with a quiet raised hand. 2 people, 3 people, 4 people. Let's go with Steph.
2.
2, yeah, so the power up there is 2. Let me alt tab back over here. And correct answer. All right. I should be taking off HP for incorrect procedure, but I think we're just still learning, so we'll be kind on the first day. What is the degree of x? I see 2 hands, 3 hands. Fiona. 1, yeah, there's a hidden 1 there. If you didn't know that, you can always put a 1 there. All right, degree of 3. What's the degree of that term? I see 3 people, 4 people with hands, 5 people with hands. Just missing 1 person with a hand. It's okay, Eva. Also 1. What do you guys think? Yep. Sadly, that's incorrect. You still get the points for trying. So 20 XP. But it's not 1. Any other guesses? James? 3. 3. What do you guys think? Shake his head. No. But good try. Good try. You still get the XP. Any other guesses? We'll go with Steph again.
0?
It is 0, yeah. Why is it 0? Okay, so this is also, well, because so many of us weren't able to get it, I'm just going to go ahead and tell us the reason why it's 0 is because I could put x to the power of 0 right here. Anything to the power of 0 is, shouts out.
0.
Uh-oh. Anything to the power of 0 is always, always, always 1. Yes. So this, now that I've written it like this, is the same thing as 3 times 1, which is just 3. That gave us our original blue number right here. So it's a degree 0 term. Cool. Now that we know that, let's talk about the degree of this term. It's not part of the polynomial because right over here I had a quadratic. If I added this, it's some weird, I'm not even sure. It'd be a mixture of I'm just going to call it a polynomial. But what is the degree of 1 divided by x? Any ideas? Any guesses? I love guesses because it gives you XP and it shows me where your mind is at.
Wait, what was the thing again?
What is the degree of 1 over x? We found the degree, and I should be labeling this. Can we go back in our notes and label this? This is the degree. And these are the terms. What is the degree of 1 over x? And as a hint, is there any way that we can rewrite 1 over x where we don't have a fraction? No? Okay, so here is, we'll do another line down here for notes. This is kind of a, we'll say review. Review. If I have 2 to the power of negative 2, what I do to this problem is I say it's 2 divided by 1 to the power of negative 2. So this is my new problem. I wrote the original problem in blue. I'm annotating it with green. What I'm going to do is a negative power means I'm going to flip it. I'm going to take the reciprocal. This problem now turns into 1 divided by 2, but instead of a negative 2, because we took the reciprocal, it's now positive 2. Notice what happened there. When I flipped it, the power switch from a positive to a negative, or a negative to a positive in this case. And then I simplify this even further, and it goes to 1/4. So if I talk about this term, I can go the reverse direction. I can go into the numerator. But if I do that, the hidden power, which used to be 1, is now what? Quiet raised hand. Ooh, lots of people. Gio. It is -1. So this thing now is x to the power of -1. I guess I could put over 1, but that's kind of pointless. So it's x to the power of -1. Good job, Gio. Therefore, the degree is shouted out, everyone. Uh-oh. I hear one person saying it correctly. -1, yeah. The degree is just the exponent that I'm looking at, the power. So when I'm looking at the degree of the largest term, which of these degrees is the biggest? 2. Yeah, it's just one of those easy questions, those shout-outs. Therefore, I'm looking at this term. So we now know how to identify the largest degree term. The largest degree term. So from there, I need to talk about if it's linear or not. So here's your giant red star. Oh, giant red star. What does that mean, Mr. Sindel, again? That means it should be in your summary. It is important. Giant red star. If the highest degree term is 1, and we're going to put a giant asterisk here, then the function is, and it's this key word up here, is linear. All right, so what I want you to do now, talk in your groups, what is the exception to this rule? There is an exception. I can find a function where the highest degree term is less than 1 or more than 1, some exception, and it's not linear. All right, so I'm going to pause the video, talk in your groups. What is the exception to this rule? Why did I have an asterisk here? Yeah, so James, your idea, something about a negative?
If the degree term is like,
I mean, no, because I think you're onto it. If the highest degree term is negative, that would be an answer, right? Okay, here's the exception. Look at this one. Y is equal to x to the power of -1. This function, the highest degree term is -1. Well, I guess the highest degree term would be 0, I guess, if you're being pedantic about it, because you could say plus 0x to the power of 0, and there's the highest degree term of 0. But for all the things that actually exist that we can see, the highest degree term is -1. Oh, so that doesn't break the rule, though. That's close. Here, I'll fix it for us, James. Are you ready? Plus x. Now the highest degree term is 1, but this is not linear. Do you know how we can check? We can check with the graphical representation. So let's table this for 2 minutes, and talk about how we can check that this is not linear. It breaks the rule. I want to really quickly, this will take 2 minutes. I want to talk about the graphical representation. All right, we're going to make a T-chart. Line right down the center, left and a right. The left side is going to be nonlinear. The right side is going to be linear. All right, linear. What do you vision when you see linear? What picture do you see? What graph do you see when I say linear? Just shout them out. A line. Yeah, exactly. So here's something that's linear. Let me make sure I have arrows on my line. That's linear. I want to do it in blue. That's linear. This is linear. This is linear. They're lines. Yeah. I mean, it's just reading into the word. Linear has the word line in it. Nonlinear means that you're not a line. Yeah, so here is a not line. It is a curvy line-ish thing, but it's not linear. It's not straight. Here's something that's also not linear. Here's something that's also not linear. I want you to try to draw some examples. What are some things that are not linear? I want to come around and see. Yeah, what are we doing? What's also not linear? Yeah, good job, James. That's not linear. Circle's not linear. No, it's not a line. It's also not a function, but it's not a line. Ooh, yeah. Some sine waves. Ooh, some spirals. Very cool. Yeah, so I saw some really cool things. I saw some people do this. I saw some people do this. I saw some people do this. All of these are examples of a nonlinear, I can't say function, of something that's nonlinear. However, let's put a bubble. I'm going to do a green bubble around these. If you have these examples, put a bubble around them. You can put individual bubbles. And if you don't have them, add them because they're important. These are very special because they're not even functions. Ooh, oh man, that was the best question I could have asked. Thank you, James. Why? Why are these not functions? Someone else answered that in the class. Why are these not functions?
Because they have nowhere else to go.
Good idea. I need to start rewarding. Yeah, so James is participating.
Yeah.
Why are these not functions? Fiona?
Well, what is a function?
Oh, that's another good question if we're struggling. A function is able to pass the, there's a certain test. I don't know if I want to give it away.
Wait, I don't know.
Oh, yeah, tell us.
It's when like you draw a line right through it. And
What type of line? Is it horizontal or vertical?
vertical.
Yeah,
And if the line touches 2 points of the same line that you're drawing it through, it's not vertical.
exactly. So, and I'm going to demonstrate this. Eva is drawing this vertical line. If it only touches once, it's a function. It's called the vertical line test. If it only touches once, it's a function. Once, it's a function. Every single one of these is a function. But if I draw a line through James's function, uh-oh, not a function. If I draw a line through Andrea's function, oh, it's not a function. Can anyone think of one other example in here that should belong in there? Yeah? Yeah, perfect. And that's one of the most famous examples. So if I come over here to arrows on both ends and do a function that looks like that, that's also not a function because it passes or it doesn't pass the vertical line test through that one point. Exactly. So everything in this green bubble, let's label that. Those also are not linear, but they're also, these guys, not functions. Okay, it was a little bit longer than 2 minutes, I realize. But let's come back to the question that we tabled. How can we tell if this thing is linear or not? Using technology. We can just see what category it belongs in, right? Let's go ahead and just plug it into a graphing calculator and see what happens. There should be not a single curve in this one. So let's look at x to the negative 1 plus x. So let's open up here. Let's go to desmos.com. Start graphing, and I'm going to graph. Come on, Desmos. I believe in you. Let's say f of x is equal to x plus x to the power of negative 1. Oh! You see that? All right, any ideas? How do we tell from a table? One person has an idea. Two people have an idea. Three people have an idea. Fiona, talk to me.
So like on the top, if it adds one, like it's adding one every time.
Add one, add one, add one, add one, okay?
And then on the bottom, it's subtracting 4.
To get to the next step, you're subtracting 4, subtract 4, subtract 4, subtract 4. What does that have to do with being linear?
It's just like even, so it goes the same way, and it doesn't.
It's even and it goes the same way. Yeah, so that's the key, right? Can you say that louder?
The number you add or subtract by doesn't change. It stays the same.
Yeah, so if you're adding or subtracting by a constant amount on the top with the x's and on the bottom with the y's, then it's linear. So let me go back over here. So Fiona, you started that off correct, and Eva finished strong. Both of you get the 50 XP. Yeah, so that's the key here. For a table, here's your giant red star.
Wait, do we have to do summers?
You're going to have to do your summaries, yeah. If x and y, that's not a y. If x and y values increase by, I should say increase or decrease. Increase or decrease by a constant, then the function is linear. I want to make a point about this, but I'm going to wait for all of us to finish writing because I want us to pay attention to what I'm about to say. It's important. Super importante. All right, we have this cool idea that if, and I don't want you to do this in your own notebooks, but if I had changed this 37 to a 38, it is no longer linear. Even though every single one of these was plus 1, each one of these was minus 4, except for this one. This one is now minus 5. It's no longer linear because not all of them are constant for the y's, even though all of them are for the x's. Nod our heads, we kind of get that? Cool, cool. All right, last thing for our notes before our summary. Slope. How do we find it? There it is, rise over run. Chris is on it. Christopher. And I guess I should write it like this. Rise over run. Is there another way to write that with a quiet raised hand? Two people remember how to do this? Andrea, yeah? Y over x. You're close. You want to change yours a little bit? Change in y. What's the symbol for change? Triangle. The delta symbol, exactly. Yeah, rise over run. All right, so let's find the slope of this equation up there. So let's assume that this was back to 37. Let's go back to 37. What is the slope of this equation? Careful. It's negative 4 over 1. Negative 4 over 1. The y's change. With each step, the y's change by negative 4. The y change is negative 4. This delta means change. The x changes by positive 1. So the answer is negative 4. Here's a second way to get there. You could do any two values that you want. I could choose this value and this value. Any 2 points that you want, this value and this value. It doesn't matter. Let's just choose those two randomly and I'll prove that this method works. As long as you choose those same or 2 points, I'm going to do the y coordinate, minus 29. And I'm going to subtract the other y coordinate, minus the negative 21. Remember, y goes on top. And then the x's are on the bottom, 3 minus 1. 3 minus 1. This is the other way to get it if you can't do the table this way. When negatives kiss, they become positive. So this is negative 29 plus 21. Shout out the answer. So lewd. Kissing in math class. Negative 29 plus 21 is, shout it out.
8, negative 8.
Negative 8. 3 minus 1, shout it out. 8 divided by, or negative 8 divided by 2 is. Same answer, different way of getting it there. That's all we have for the notes. Yes. XP for, everyone shouted at negative 4 though.
P for negative 8.
Yeah, I usually give XP to encourage people to be isolated and have to volunteer. When everyone's yelling it out, it's not so hard. All right, so summaries. You should have this in your summary, and you should have this in your summary, and maybe something else.